Every time Christopher Sullivan takes a research ship to sea, it costs $1 million. And the nightmare scenario:
if I came back with no data, that would kind of be bad.
the ocean isn't the challenge, the visibility is. Sullivan can collect terabytes of images, but he can't process a single frame in real time.
Edge AI has always been a problem because of power. GPUs gobble up power. I have no cooling out there other than the ocean and the ocean air.
So he sails blind, hoping the system captured what he needed. And that's not easy when the focus of his search is as tiny as plankton. Microorganisms that drive half of the planet's oxygen cycle and support the entire marine food web.
If we shoot a laser through a pinhole and cast a shadow, by using the physics of light, we can actually get them to be enlarged, and I can film them. And so it's a shadow graph, so it's sparse data. It's not hard edge, and so it's very difficult to process.
But the reason Sullivan keeps coming back is what the data is starting to reveal.
You have predator and prey relationship happening. They look like they were mixing, and we've learned by using the system that they're not. And so the temperature is separating out species in the water in such a way that we're not building the lower parts of the food web to get the larger mammals, larger animals, and larger fish into play.
It's a major discovery, but one made only after the trip is over. He needed to process at the edge to turn his ship into a live observatory. But the challenge?
Every time I try to stick other pieces of equipment out, they would say, too much power, we don't have the cooling to cool it.
High-density SSDs flip that script.
SSDs, compared to hard drives, help reduce your power emissions by a factor of 80%.
With Solidigm's SSDs, Sullivan gets massive storage in a compact, low-power footprint. Nearly 250 terabytes in one chassis. That's what keeps the GPUs running at full speed instead of throttling.
It's better to have high density on a single drive versus having multiple drives achieving the same density, because having multiple drives increase power, increase cooling consumption, increases heat dissipation.
And so by talking with Dell, we were able to identify the XE7745 would fit in the power envelope. By putting Solidigm in, I did not change my power, I did not change my cooling, but I brought in all the disks.
Sullivan has now validated this Dell and Solidigm system on land, proving it can handle the enormous flood of imagery his cameras capture. The next step? Taking it to sea. Aboard a new $150 million research vessel designed to carry an onboard AI data center. For the first time, scientists won't just study the ocean after the fact. They'll be able to watch its changes as they happen. And we'll be here to report on them. So follow along. Till next time, I'm Diana Blass.